Hello guys, in today's video we are going to discuss the solution of the problem minimum cost to make two strings identical. So let us look at the problem statement. The problem statement says that given two string x and y and two values cost x and cost y, the task is to find the minimum cost required to make the given two strings identical. You can delete characters from both these strings. The cost of deleting a character from string x is costX and from y is costY. The cost of removing all characters from a string is the same. So let us try to understand the problem statement with the help of an example. So over here in this example, the string x which is given to us is abcd and the string y is acdb, and the value of cost x is 10 and the value of cost y is 20. Over here, in order to make x and y identical, we need to remove b from both these strings. So this b can be removed from string x and this b can be removed from string y. After doing so, string x and string y becomes equal. So the cost will be 10 plus 20, which is equals to 30. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the solution of this problem is rather simple. What we need to do is we need to find the LCS of string x and y, and once we find the LCS of string x and y, then we need to compute the cost to make x and y identical. So let us try to understand this with the help of an example. So let us take the same example which we have, where the string x is a, b, c and d and string y is a, c, d and b. Now over here, if we compute the LCS, so LCS is longest common subsequence. So the longest common subsequence between these two strings is ACD. Now once we have computed the longest common subsequence, then it becomes very easy to compute the cost. So let us see what will be the cost. Well, the total cost will be equals to how many characters needs to be deleted from x. Well, the length of LCS is 3 and the length of string x is 4. So the number of characters that needs to be deleted is 1, and multiplied by the cost of x plus the number of characters that needs to be deleted from y. So over here also the number of characters that needs to be deleted is 1 multiplied by cost of y. So in this way the total cost will be, and over here the value for cost of x is equals to 10 and cost of y is equals to 20. So this will be equals to 10 plus 20, which is equals to 30. So that's about the whole discussion of the solution, folks. Now let us generalize this. So if L is the LCS of x and y, then the total cost will be x dot length minus L multiplied by cost of x plus y dot length minus L multiplied by cost of y, and in this way we will be able to compute the cost or the total cost which is required in order to make string x and y identical. So that's the whole idea, folks. And now as you can understand that the important concept which we need to understand from here is how do we compute LCS optimally. So let us look at the algorithm for computing LCS optimally. So in order to understand the algorithm for LCS, let us take two strings. So let us say the first string is ABCD and the second string is ACDB. And we want to compute LCS, which is longest common subsequence, which is essentially the length of the longest common subsequence. So the way we are going to do is, so in order to compute this optimally, we need a DP table of size x dot length plus 1 and y dot length plus 1. So this will be the size of our DP table. So this is a two-dimensional vector and the number of rows is equals to x dot length plus 1 and the number of columns is equals to y dot length plus 1. Now let's make a DP table. So let us say this is our DP table. Now please note the indexes 0 to 4 and over here also 0 to 4. So this is my string x and this is my string y, and my string x starts from index 1. So a, b, c, d. Similarly, the string y starts from index 1. So once we have this, what we are going to do is we are going to compute the LCS for the cases where either I is equals to 0 or j is equals to 0. So essentially we'll have two counters where I is equals to 0 and j is equals to 0, and I will range from 0 to length of x plus 1. Similarly, j will range from 0 to y dot length plus 1. Now for the cases where I is equals to 0 and j is equals to some value, so I is equals to 0 simply means that this is an empty string, and this is j is a string of some length, and please note j is coming from a string y and I is coming from a string x. So we are trying to match an empty string to y. Now since empty string exists in all these strings, because of which the LCS will be equals to 0 because the size of the empty string is 0, because of which all these row which you are seeing will be equals to 0. Similarly, the 0th column will be equals to 0. Now once we have this, now let us proceed with I is equals to 1 and j is equals to 1. So for I equals to 1 and j is equals to 1, what we are going to do is we are going to compare the ith character of x and jth character of y. So over here, when we are comparing the ith character of x and jth character of y, then these are the two conditions which are possible. Over here, xi is equals to yj, and over here xi is not equals to y of j. So in the first case where the ith and jth characters are equal, then we know that now the LCS is at least 1 plus the LCS between x of I minus 1 and y of j minus 1, right? And in the case where they are not equal, so over here, so in the second case when they are not equals, so the new LCS will be equals to LCS of x of I minus 1 comma y, or LCS of x of I and y of j minus 1. All the characters from y, so over here what I am doing is all the characters from y and I minus 1 characters from x, and I am comparing, or I am computing the LCS there. And in the second case what I am doing is all characters from x and j minus 1 characters from y. So in this way I am computing the LCS, and whichever is maximum over here, that will give us our LCS. So now let us apply this logic in order to complete this table. So over here a and a are equal, which simply means the LCS is equals to 1 plus LCS of I minus 1 and j minus 1. So the LCS of I minus 1 and j minus 1 is here, and 1 plus 0 is 1. Now j is equals to 2. So over here a and c are not equal. So that simply means we need to compute the LCS between I minus 1j and j minus 1i. So that simply means is we are comparing these two values, the diagonal values, and we are seeing which one is greater between them, and that will be our LCS. So over here the LCS is 1. Now moving forward, a and d are not equal, so we know the drill. We have to compare between these two values, and whichever is maximum, that value will come over here. So over here this is 1. Similarly a and b, again they are not equal, so the maximum between these two, which is 1, so 1 will happen. And intuitively, if we want to understand the LCS between string x, where x is a and y is a, c, d and b, the longest common subsequence is a. That is why you are getting the LCS as 1 over here. The length of the LCS is 1. Similarly, for the case where x is equals to a and y is equals to a, c, d, in this case also the longest common subsequence is a itself, because of which the LCS over here is 1. Now let's proceed forward. Now for the case where I is equals to 2 and j is equals to 1, so over here the string x is equals to ab and the string y is equals to a. So over here b is not equals to a. That simply means the LCS will be the maximum of these two strings. So over here the maximum is 1, so that is what is coming over here. Now let's apply the same logic to fill the rest of the cells. So b and c are not equal, so the LCS will be 1 over here. The max between these two is 1. B and D are not equal, so the LCS over here is 1 again. Here B and B are equal, so in this case the LCS will be equals to 1 plus the LCS of I minus 1 and j minus 1, and please note I minus 1 and j minus 1 is the diagonal value, which is equals to this, and 1 plus 1 is equals to 2. So if you want to understand this intuitively, so here the value of x is AB and the value of string y is acdb, and between these two the LCS we will get is AB, whose length is 2. That is why we are getting 2 over here. Now let's proceed in order to fill the rest of the cells. So for the case where I is equals to 3 and j is equals to 1, c and a again are not equal, so the LCS will be 1. C and c are equal, so 1 plus 1, so 1 plus 1, and the other one is coming from this diagonal, which is equals to 2. C and D are not equal, so over here the LCS will be 2. The max between these two is 2 now, because of which the LCS is 2. C and B are not equal, so over here also the LCS is 2. Proceeding forward, A and D are not equal, so the LCS is 1. B and C are not equal, so the LCS is 2 over here. D and D are equal, so the LCS will be equals to 1 plus the value in the diagonal, which is equals to 2, which is equals to 3. Now D and B are not equal, so the max between these two values is our LCS, so 3. And towards the end, what we need to return is this last value. This is the LCS between the string x and string y, or the length of the LCS between string x and y. And in this way we will be able to find the LCS, and once we have found out the LCS, then in order to compute the total cost will be computed using this formula. So that's the discussion regarding the LCS. So now let us discuss the pseudocode for this problem. So first let us discuss the pseudocode for LCS. So over here x and y is given to us. So what we are going to do is we are going to take a DP table whose size is equals to x dot length plus 1. So the number of rows is x dot length plus 1 and the number of columns is equals to y dot length plus 1. So now we will iterate on x and y. So for I in range length of x plus 1 and j in range length of y plus 1. Now let us write down the pseudocode for the cases we have discussed. So for the case where I is equals to 0 or j is equals to 0. So this is essentially a case where we are trying to compute the LCS between an empty string and the other string. So as we have discussed, the length of the empty string will be equals to 0 and that will be the length. So in such cases, the DP table I comma j will be equals to 0. Otherwise, if x of I minus 1 equals to y of j minus 1. If the ith and jth characters are equals, in such cases, the DP table I comma j will be equals to 1 since they matches plus the I minus 1 and j minus 1th entry, which is the diagonal entry. And the last case, which is if they are not equals, then in that case dp of I comma j will be equals to max of dp of I minus 1 comma j or dp of I comma j minus 1. So this is how we will be able to find out the LCS, and then towards the end we are going to return the LCS, which will be equals to dp of x dot length comma y dot length. So once we have the LCS with us, then let us discuss the code of computing the cost also. So let us say we want to compute the total cost. X and Y is the string which is given to us. So using the above, we will find the LCS. So LCS will be equals to LCS of X comma Y, and we will get our LCS. Then simply what we need to do is return the total cost. So the total cost, as we have discussed before, is equals to X dot length minus LCS into cost of X plus Y dot length minus LCS into cost of Y. And in this way, we will be able to compute the total cost to make the two strings identical. So that's the pseudocode, folks. Now let us see how we have implemented this in C++. So what we are doing is, the first thing which we are doing is computing the LCS. So the first thing which we have to do is we have to take a DP table of size x.length plus 1 and y.length plus 1. Then we are iterating on the DP table. If one of these string is an empty string, then the DP table entry will be 0. Otherwise, if they are equal, then it will be 1 plus diagonal entry, which is v of I minus 1 and j minus 1. Otherwise, the max between these two. And then towards the end, we are returning the last entry of the DP table. So once we have the LCS with us, we are computing the cost using the equation we have discussed. And then towards the end, we are returning the output. So that's the whole code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.